Okay, hello everyone. Am I audible to all of you? Okay, I think Shobna, are you there? Shobna, are you there? I think Shobna forgot to share the presenter rights. Just give me a minute. We'll start in a minute. Okay, let's start. So we yesterday we had done logistic regression, then we had done support vector machine and naive Bayes, right? Is that correct? Right? So today we're going to start with KNN, right? And then after KNN we'll start with decision tree and random forest. Okay, so let's get started without wasting a minute. And can you see my screen now? You can see my screen? Okay. So KNN. Okay, before that, let me share with all of you. I've shared the name base. Yes, I did share the name base, right? Name base is there, right? So just give me a minute. I'm sharing the files for decision tree and lodges and random forest. Okay, and name base, it's just sorry, this KNN is just a R file, right? Maybe you will not require this, but let me share this as well. I'll have to compress it. So KNN and decision tree and random forest. So you can take out these. Okay, perfect. So let's start with KNN. KNN means K nearest neighbor, first of all. Okay, so we have seen support vector, now KNN. Okay, so KNN means K nearest neighbor, where K is a variable, okay, which you can decide on your own. Rather, which you have to decide before um, you run the model. That what is the value of K, right? What is K? We will discuss that. K is a number. K is a numeric. K can take numeric value, and K nearest means K nearest neighbor. It's a algorithm that classifies data points by majority vote of its K neighbors. Now, this is. Am I audible? Is my voice? Is there echo in my voice? No. Okay. So I think I can continue. Indu. Am I audible now? Indu, am I audible? No echo now? Okay, let's continue. So, k nearest neighbor means it's an algorithm that classifies a data point based on the majority voting of its k nearest neighbor. K neighbors means if let's take a look at this picture, it's very comprehensive and very easy to understand. Let's say these are three groups you can see, right? Group red, group blue, group green, right? Now, when new data point comes in, question mark is the new data point, right? Now, what will k nearest neighbor do is we have to first define that what is k, as I said, right? Let's say in this case, k is 5, means it will use the Euclidean distance formula. Euclidean distance formula is the formula which helps you determine the distance between two data points. Okay, I'm sure you would have, uh, I mean, you would have done that in your high school. Let me quickly. It's like this: x1 minus y1 whole square plus x2, which is the second data point. Sorry, I think it's my bad. It's x1 minus x2 and y1 minus y2, right? So, okay, I'll show it to you. Just leave it for now, right? So, using this Euclidean distance formula, it measures the distance between five nearest neighbor. It will pick up the five nearest neighbor and do the majority voting of them. So, like in this case, you can see the five nearest neighbor. Among the five nearest neighbor, majority voting goes with blue. So it is going to classify this new data point in the blue bucket or triangle. Is that clear? Very logical. I mean, I'm sure many of us do majority voting even when you probably want to take uh, maybe suggestion from, let's say, 10 of your friends, right? And you wanted to buy a home and you want to take suggestion from 10 friends. So what will you do? You'll ask them and then do a majority voting. We very, I mean, in our daily lives, we use majority voting a lot, right? It's that same thing. Is that clear? Is it clear to all of you? Right? So, but the only thing here is that you have to define the K you will be using initially, right? That is the only, you can say it's a kind of a drawback also, or I mean, because you have to define and initially you don't know, then you can, of course, maybe once you run the model, you can play around and see how the results are coming with the K as well, right? We'll see this. Okay, it is used to assign the data point to clusters based on similarity measurements, right? So there are three clusters you can see, red, green, as I discussed. So based on the similarity measurement, or rather I would say majority voting is a better word, right? A new input point is classified in the category such that it has the most number of neighbors from that category. Is that clear? The the logic is clear. What happens in k nearest neighbor, right? Rest the model will run. You don't have to do any calculation on your own, right? So, okay. Choosing the value of k. Idris, I'll explain the logic once again. Can you see three different clusters, Idris? Red, green, blue, right? So that's your historical data, right? That's your historical data based on which you will create a model. Okay. Now, what will the model do? Model is going to, when you put in testing data, right, or any new data in it, in the model, let's say that it's going to model will pick each data point one by one, right, and classify it, right. Let's say this question mark is the data point model is working on, right. It wants, it is classifying this question mark. K nearest neighbor means it is the algorithm will classify the new data point taking into account the nearest k nearest neighbor. In this picture or in this chart, we have defined k is equal to 5. How? It is taking 5 nearest neighbor. Can you see? It is looking at 5 nearest neighbor, and how does it pick the 5 nearest neighbor? Using the Euclidean distance formula, which is x2 minus x1 plus y2 minus y1 whole square, and sorry, x2 minus x1 whole square plus y2 minus y1 whole square, and whole under root. I'll show that to you, right? So using that formula, it calculates the distance and pick the five closest neighbors. Hence the name k nearest neighbor. Okay. Now it will look at these neighbors where maximum, or it will do a majority voting to be on the easy side, right? It will do a majority voting like this. Like here, it is doing this question mark, which are the if we do a majority voting, blue scores 3, right? Red 1 and green 1. So my question mark will be classified as blue by majority voting. Is that clear? Idris, now it's clear? Got it? Okay. So that's the logic it will apply on any new data. Okay. Now, how do you define K? As I said, K is a tricky thing to define, because as such there are no guidelines to define K, right? But what happens is, you have to keep this in mind. As such, there are no, you can say, guidelines or no ways you can define A, but the following two things should be kept in mind. If the value of K is too small, right? Let's say 2 or 3, and the data is very large, 2, 3, 4 is the value, let's say, right? The neighborhood is sensitive to noise. The neighborhood would be sensitive to noise points. Noise points means the points that are, I mean, they are not part of any cluster, right? But they will become part of the cluster because my k is very small. Okay, so they will impact my classification. Now, if the value is too large, neighborhood may include points from other classes, right? So this is all what you have to just keep in mind. Otherwise, I mean, so what you'll do is you'll probably will see when we run the model, we are going to uh, pick up K. We are going to run model with multiple Ks and then see where does my accuracy is maximum. And once it is maximized, we will also uh, try to optimize that. That okay, at what point now it has maximized and it has stabilized. Okay, so wherever it is stabilizes, and we will pick that, or maximized, we will pick that as K. Okay, we'll see this when we run. Now this is the Euclidean distance formula that I was talking about. X2 minus x1 whole square plus y2 minus y1 whole square. Okay. So using this formula, you can it calculates the distance. So that's it about the concept. Now let's go to R. and I think most of you would have downloaded this package except for class. So download this class package, and class package, I think this is the package for uh, classification models, K-nearest, I think. It is used along with, I think this package works at the back end with K-nearest neighbor. Okay, so just keep this package activated. Okay, um, so quickly activate these three packages: E1071, class. KNN is a package for class. Okay, so fine. Okay, so quickly do it. Once you install this, once you activate these three, iris data is what we are going to work on. I want you to do till line number 35, that is cross validation. So set the seed, and once you set the seed, sample dot split. We will be using sample dot split to split this data, iris data, into two parts. First part, which will be the training data, will have 70% of the observations. That is why I've kept split ratio is at 7 by 10. First part will have 70% of the observation. Second will have 30%. And then we use subset to split it into test and train. Do till 40, line number 40. Because we have already done this, so I've just quickly explained it. We have already used sample dot split, right? Once you're done till line number 40, let me know. Okay, thanks for the confirmation. I'll wait for others to confirm. So done till 40. Others? Now, as we have done earlier also, we are rescaling this data, right? Scaling it to bring them on the same scale. So scale this data. And we will only scale column 1 to 4 because fifth is the one that we have to uh, predict, right? Fifth is the dependent variable. So we are going to scale column 1 to 4 anyways because fifth we cannot scale also. It's a categorical variable. So once you have scaled the data, scale the train and test data, you are ready to create a KNN model. And the command is very simple, KNN. And within that, I will first mention the data, right? Training data as well as test data. Now this has a slightly different syntax, right? Or slightly different structure of the command. Train data, you mention the test data, and then you mention the class data that you will classify, and mention the K. Right now I am picking K as 1 only. Once I run this, line number 49 to 52, so it has created the output, rather it has given the output, right? Now once you have the output, I will apply this model this model name, this is the model name, right? Classifier underscore KNN1 on test data, and create a table. Just create a table that is the confusion matrix to get the accuracy of this. So what will be the accuracy? 20 plus 18 plus 18 divided by 20 plus 18 plus 18 plus 2 plus 2. Accuracy comes out to be 93%, right? Now, what is your accuracy coming to be? Couple of you can just let me know. What's your accuracy coming out to be? Okay, if you're writing, fine, write it and then let me know. What's your accuracy coming out to be? Am I audible? Hello, am I audible to all of you? I don't know if I'm audible. Am I audible? Can someone please respond? Okay, fine. So, that's good. That's good. Okay, 91.7. Okay, fine. So, Idris, now once you have calculated this, no need to calculate the misclassification error. It is simply 1 minus the accuracy, right? So, if I calculate the misclassification error here, it's misclassification, 1 minus misclassification I'm doing. Well, misclassification is coming out to be, see, 0.6. This is not required, right? I've just done it. Otherwise, these line number 70 and 72 not required. Okay? You can ignore them. Okay. So, you have calculated the accuracy rate, right? It comes out to be, it came out to be 93% for me, and for some of you it came out to be 91, 92%, right? Now, change the K. Let's calculate the same thing for K. So all you have to do is just copy that same formula or copy that same code and paste it here and just change K is equal to 3. And then again run it. Accuracy, my accuracy again came out to be 93.3. Otherwise, you can calculate it this way also after you create a confusion matrix. So if I create a confusion matrix, this is how my confusion matrix look like at K is equal to 3. Coming to K equal to 5, I have, my values are coming different because I did not run set seed, right? So don't worry, they can be slightly different. Okay. Okay, for Idris, K is equal to 3, 97%. Very good. I think, let me also run, it will be better. Let me run set seed and then again I'm going to do a sample split. So for K is equal to 1, my confusion matrix, let me check what will be the, yeah, even, yeah, it comes out to be, for me also it comes out to be 97%. Now, because I think I've also taken that same set seed. Okay. So, is this okay? K is equal to 5. If you try K is equal to 5 and see, again 97%. Yeah. So that's how you can just try multiple case. I have tried for 7, 15, 19 also. You can just pick up different case and see where does it stabilizes and where do you get the maximum accuracy, right? So if I just pick for 15, I'll just maximum I'll do for 7 and see what is the accuracy coming. For 7 also it's 97, right? So I think it has stabilized. If I 15 also it's same and 19 also it should be same, right? So it means k is equal to 3 is good for this data set, right? Because it has from k is equal to 3, it is just moving consistently. So I would not want to complicate the model unnecessarily by increasing the value of k. Okay, is that clear? Choosing the optimal k, I have picked up some more points. There are no predefined statistical method to find the most favorable value of k. Initialize a random k value at the starting point. Choose a small k. Choosing a small k will lead to unstable decision boundaries. The the substantial k value is better for classification as it leads to smoothing the decision boundaries. Higher the value of k will lead to higher usage of computing power. So what it is saying is you can I can take 19 also k, but there is no point taking 19. At the most, I'll take k 3 or 5 or maybe 7. Okay, just to uh, make sure that the noise does not impact my data. I am taking a slightly higher value than k. I mean, maybe I can take a higher value than 3. So 5 or 7 I can easily take, and it will also prevent noise from interfering in the model. Is that clear? Is this clear? KNN, any questions in KNN, let me know. Else we will proceed to the next model, which is very, very important model and a very interesting model also, decision tree. Any questions? Any questions on KNN? If no, we can proceed. Others? So I believe no question, right? Okay, so let's move to next model, decision tree and random forest. So first we are going to learn, first we are going to do decision tree and then we will do random forest. Okay, just give me a minute, right? So what is a decision tree? Let's first understand what is a decision tree. It's a classification algorithm, first of all, right? Decision tree is a classification algorithm. It classifies the um, data. It it can be of two types: classification as well as it can also be used for regression problems, right? It's a first important point is it's a supervised learning model. Okay, it's a supervised learning model. What is a supervised learning model? You know, you know it very well. What is a supervised learning model? Yes, it is with labels. Correct. It is a model with labels and predefined labels. Correct. And they are labels is there, and plus there is a output variable also. Correct. Input and output both. Right. So that is these are the two keywords I wanted to hear. Right. So the goal of decision tree algorithm is to create a model that predicts the value of the target variable or the output variable. Right. This is done by learning simple rules based on prior data. Right. Now, what you do in decision tree, you create based on some prior data, you analyze those data and create some rules. Remember when we started with the classification day before yesterday, I showed you professor example, tenured and not tenured. Remember? That was a classification. That was a small example of classification. We are going to do another example on classification, right? So don't worry on that. We will do that. But for now, understand based on historical data, you create some rules. Okay. So the decision tree is used. Okay, predicts the value. This is done by learning simple rules based on prior data, okay, or training data. The decision tree uses tree representation to solve the problems in which the leaf node corresponds to class label. So forget about these. I am going to discuss this in the next slide in detail. For now, just understand it uses the historical data and creates some rules. Okay, is that clear? Okay. The rules based on which decision tree is created is equal to the number of terminal nodes. Again, just so let's do this. I'll come back and read this again. Once we understand the different, sorry, once we understand the different, how do you create a decision tree, then I'll come back and I'll again read this. Right? It will be much easier for you to understand that. Right. So let's understand some terms related to decision tree. How is the tree created? How is the tree built? And how do you take the decision based on tree? Okay. So first, what you do is you put the you put all the data, right? Especially the dependent variable, right? You put the entire dependent variable data in the first node, and this is called the root node. Okay, it is the starting point of the tree and is called the root node or the base node. It contains the entire population of the model, especially the dependent variable. Okay, then after you put this, then the splitting process start. Splitting is the process wherein you bring in independent variables and Based on those independent variables, I start splitting the dependent variable which is put in the decision nodes. Okay, so splitting is a process by dividing the node into smaller nodes, two or more, right? So this is called a decision node. This is called a root node, but it is also called a decision node. Decision node is a node which is split into further smaller nodes. Okay, any node which is further split into smaller nodes is called decision node. So this, even being a root node, it is a decision node also. Okay, it is in this node that we take decision based on rules. Okay, it is in this node we take the decision based on rules. Okay, now once a tree is built, right, and you come up to a point where no more data can be split further, right, that node is called the leaf node. Is that clear? So that node will be called a leaf node, which will not be further split. Leaf node, or it is also called terminal node. The last node of the tree that cannot be split any further is called the leaf node or terminal node. Okay. Also, this is, as you can see, the sub branch, the one branch of the decision tree is called subtree. Okay. Last thing, pruning. You know what is splitting? We just discussed the process of dividing a node into smaller nodes is called splitting. Pruning is just reverse of splitting. We are just moving up. We are, suppose I have split the tree, I have built the tree to such an extent that was not required. So I can prune it also by removing the sub nodes of the decision node. For example, this. I did not require this. After I built it, I realized it was not required. So I can prune this, remove this, and here only I will terminate it and I'll call this a leaf node. That's called pruning. Is that clear? So the concept is clear on decision tree, right? Now what we'll do is, let's go to Excel and let me build a decision tree, and it will really help you understand how the tree works, right? How in decision tree we take decision. Okay, so let's take an example of bank, right? Bank loan. So we have discussed it. Whenever you go to a bank, they ask you lot of information, and then they'll take a couple of days, and then they will decide whether to give you the loan or not, right? So let's see the process of a bank giving loan. So historical, just a second. Okay, so historically, let's say bank will bank is studying, or bank is creating or analyzing rather 1000 customers. Okay, it is analyzing 1000 customers, and the data it has collected is for age, education, and employment status. Very simplistic case. Okay. Age, it classifies the age into two brackets, and these brackets are 25 to 60, and the other bracket is uh, less than 25 and greater than 60. Of course, I can create three brackets also, but I am just taking a very simplistic case. Okay, education is grad or a post grad. Of course, there can be people those who are less than graduation also, right? And more than post graduation also, PhDs also. But I am again taking a simplistic case. Employment status, very simple. Employed, not employed. Okay. So of these 1,000 people to whom bank had given loans, right? Uh, uh, Sorry, of these 1,000 people for whom we are analyzing, right? Bank has uh, people who has defaulted. Let's call it 1 and 0. People who have not defaulted, 100 and 900. 900 people did not default. I call it 0. So let's call it defaulted or not. So 1 means defaulted, 0 means not defaulted. Okay. So let's, did you get the clarity on the data? What is our data? Everyone, are you clear on data? Because I'm going to use this data to build the tree. So I want everyone to be very clear on this. Okay. Okay. Now we are going to build the tree. And as I said, first we will bring in the I bring the entire population in the root node. So I'm going to first create a root node, and it includes 1,000 historical data, right? It includes 1,000 of this, you know, 100 defaulted and 900 did not default. Okay, let me put this. Clear? I hope it's, I mean, you are able to understand it, right? Right? So now let's start. This is our root node. So let's give a color to it. It's my root node. Now I start bringing in independent variables, and I bring in the first variable age. Okay. So when I analyze the age of these 1,000 customers, right? What did I come to know? That less than 25 and greater than 60, this bracket, 400 customers were there. 400 customers were from this bracket, or let me put it, yeah, 400 customers, correct, right? And so let's give another color to it, because so 400 customers fall into this bracket, and the other side between 25 to 600, oh sorry, 60, 600 customers were there. Okay, and when you further dig deep and you analyzed how many of them defaulted, so 75, right? And uh, let's do it 70, and 0, 330. Clear? Are these numbers clear to you? Okay, let's talk about this. How many of them defaulted? 30, correct? And how many did not default? 570. Okay, so first variable. Now, if suppose I had to end my tree here, right? Which bracket will I go with? Where there is less default, isn't it? So I'm going to go with this side, right? Because the default rate is very less. Here the default rate is very high. So here the default rate is 70 by 330, sorry, 400. 17%. And here the default rate is 30 by 600. 5%. Okay? Got it? Now, this was age. Now we bring in another uh, variable, that is, sorry, it's already there. Age, and next is education. We bring in another variable, education, and I further split this by education, right? So grads, postgrads. Okay, let's now I split this. So when I split it further, of these 400, 250 were grads and 150 were postgrads. When again I split it, and I found that of these 150 grads, let's take this ratio a little bit higher. It will be easy to, let's 107, right? Okay, fine, that's fine. So of these grads, um 50 defaulted and 200 did not default. Okay. On the other hand, postgrads, 20 defaulted and, sorry, 20 defaulted and 130 did not default. Okay. Are you getting it? How I'm building the tree? How the tree is built? I'll quickly do one more on the other side, and then we may not do the third level. I'm sure you would have understood it by now. So here, within this, is this also called stratification of data? Kamalpreet, stratification, I don't know whether it is called, but yeah, you're right. We are actually uh, kind of doing, I think stratification, stratified sampling is, I know something, but I don't know whether this is also called stratification of data. So maybe I'll check and let you know. Okay. But I've never heard of stratification of data as such. Maybe you can check on the web or maybe give me time. I'll just check. Okay. Okay. In Lean Sigma, it is called. Okay. Then maybe in Lean, they might have a terminology, right? So they might call it stratification there. Okay. Yeah, actually it is, yeah, it looks like stratification only because stratification is that based on your based on the features you are drilling down, right? And that is what we are doing here. Okay. So I think, but in data science we don't have that term. That's what I'm saying. If you compare it with Lean Six Sigma and the thing, I mean, this it's the same process that you're doing there. You can call it stratification, but as such, it is not the term in data science. Okay. Perfect. Next. So what did we do uh, here? Of this 600, I had 200 grads and 400 postgrads, and 30 defaulted and 170 did not default, and all the 400 did not default here. Getting it? All of you got this? Now, if I check the default ratio here, right? So let's check the default ratio here. It turns out to be 50 upon 250, right? Here it is 20 by 150. Here it is 30 upon 200, and there it is 0%, right? Is that clear? Right? So I can, of course, I can bring in the third employment and again I can build it, but I mean the concept is clear. I mean the broad uh, concept how you build the tree. Is that clear? Now you might say that, oh, okay. So what will happen if a customer if for me a customer, so how will I create rules? Yeah, right. The rules. Let's create some rules here. And how many rules are there? Okay, first tell me this is my root node, right? And these two are decision nodes, right? Everyone with me? These are decision nodes, correct? And what are these nodes called? The one in blue. If you can try and recall, if suppose I am not leaf nodes, very good. So these are my leaf nodes. Okay. Now these are my leaf nodes. Let's create rules now. Now how will my rules be created? If age is between 25 to 60 and he is a grad, the customer that is coming or the person coming from loan is a grad, right? So my default rate is 20%, isn't it? So this is my root, right? Default rate is 20% historically, right? If age is, sorry, I age is between, yeah, my bad. Its age is less than 25 and greater than 60. And grad, it's 20% if age is between greater than 25 and he's a post grad, right? So the default rate is 13%. Similarly, two more rules will be there. For age is between default rate here is 15% for grads, and for postgrads is 0. So 15% and 0%. Now these are the rules we have created, and the number of rules that you can create in a decision tree are equal to the leaf nodes. Always remember this. Okay, so you can see I have created 4 rules and I have 4 leaf nodes. Right? Is that clear? Is that clear to all of you? Right? So now, if suppose a customer comes to me and uh, the customer comes to me and he is is between the age of 25 to 60, let's say 30 years. The customer is of 30 years and uh, is a postgrad. Should I be giving loan to him? 30 years and a postgrad. Yeah, the default rate is very less, right? So I will definitely give loan to him if I'm a banker in this situation. Now, if the customer is for, let's say, 65 years and it was only a graduate, right? You're 65 years and a graduate. Should I give loan to him? It's my highest risky, most risky bracket, right? So I would probably not give loan to him depending on the thresholds, depending on other parameters of business, right? Depending on the thresholds. I mean, sorry, the other how I'll consider some other parameters and maybe take business um, experts' advice, right? But here I will definitely, most probably, I'll reject here. But here I can, what I would do is, all of you know that sometimes when your CIBIL rating is not good, then the bank give you loan, but at a higher rate, right? So they might put some riders here. They might make loan costly for you, right? So these are some other things bank can uh, do. Okay, what they can have different options here. Is that clear? Right? So this decision tree that we created, it will hopefully it will make your make you understand how the decision tree is created, how the rules are created, and then how based on those rules decision is taken. Okay, right? So what we do is we will okay continue now, and now I'll go back to this slide and you will be able to understand this. The decision tree uses the tree representation to solve problems in which leaf node corresponds to the class labels. So notice that all the leaf nodes that you're bringing, oh sorry, the leaf nodes represents the class labels, okay, and attributes are represented on the internal node of the tree. So we have attributes. These are the attributes. Based on these, the tree is prune, okay, or tree is build rather, right? The rules based on which decision tree is created is equal to number of terminal nodes. Is it clear now? The terminal node count. Now this is important. The terminal node count should not be greater than 10%. What is it saying? The count within this, the terminal node. See, if I don't put a stop where the I see in a real scenario, on not just three data point. Oh, sorry, the there will not be three variables. There could be 50 or 100 variables that the bank collects the data points, right? Or 50 or 100 information that uh, bank bank collects, right? Your location, address, age is already there. Then maybe marital status, family members, right? What is your job's designation and all that, right? It collects lot of information. If banks start bringing in all those information, right? The tree this splitting will not stop, right? So I have to put a condition that where do I beyond which I would not go. Otherwise, what will happen? The tree will not stop. I'll keep the see because it is automated. I mean, the software or the algorithm rather, it's going to keep on building the tree until you have split it to the maximum point. And what will be the maximum point of split? Wherein you will only have one observation in one leaf node. So, so to that extent, the tree can be split. And if you think it, if you just try to um, analyze this, it is overfitting, right? What was overfitting in regression? This is in decision tree. This is called overfitting, wherein you don't stop uh, the tree to build and you let it build and it keeps on building. You it keep on providing more categorical variable, more input variable, and the it is not going to stop here or with next level, but it is going to be built wherein there is only one data point in each leaf node. Okay, are you getting this point? And that is called the overfitting of tree, right? But I have to put a stop somewhere, right? So I can define where I have to put a stop. Usually, the terminal node count. Usually, this is a very common, you can say, parameter we define, that the terminal node count should not be greater than, wait, should not be less than 10%. It should be less than 10%, right? So it means if the terminal node counts become less than 10%, let's say here we had 1000, if on the third split, one of the terminal node had a count of 90, which is less than 10%, which is less than 100, right? After that my tree will not be built, and this is called, uh, the tree will not be built and it will stop, right? And this, so from there, this particular, the leaf node, the tree will not be split further. Is that clear? Or the tree will not be built further. Is that clear? Are you getting my example? Yes? No? Any response? Kanupriya responded. The last part is not clear. Idris, I'll explain again. I'll explain again. Idris, I'm saying what happens is, I'll explain it again, right? If, see, I can bring in this was a simplistic case wherein I had brought in only three variables, right? But when you go to a bank does not collect data for three or four variables or three or four data points, right? They would collect at least 50, 60 data points or even 100, right? So they don't have any dearth of bringing more variables, right? So if you have more variables, you can keep putting in more variables, and this tree will keep on building, right? And to that extent, that each leaf node, if I don't stop it from building, my algorithm will keep on building it till the point that each leaf node will have only one data point. Think of it, 1000, right? 1000 observations and 1000 leaf node got created because I did not stop it from building. It's an algorithm. It will keep on building. Are you getting this, Idris, now? So this situation is called overfitting. Overfitting, because now my each leaf node, has become homogeneous, right? Homogeneous means it there is no it, I mean the all the data that is there, there is only one data point, right? So it has become homogeneous, right? So can a tree have two variables in it? Tree has two variables, you mean this data point? No. It can't have, see, this data point that I am creating, this node that is created, it is only having my dependent variable. Independent variables, I am bringing them one by one to split this dependent variables. Okay? Okay? So if I don't stop this tree from building, it will keep on building, and to a point where I have only one data point in one node, in one leaf node, and that situation is called a overfitting, that we have overfit the tree, and all the leaf node have become homogeneous. But that is not an ideal situation, right? I would not want my tree to be overfitted for the same reasons, that when new data will come in, its overfitted tree will flat, I mean, will fall flat, right? It will not be useful. It will not fit the general trend, right? So I have to put a stop somewhere. Where do I stop? Usually you keep, there are other, you'll see there are some other criterias also, but this is a very common criteria that I keep this criteria that the terminal node count should be less than 10%. So in this case, my 10% of the total, right, of the total data. In this case, what is my total data? 1000. So if my terminal node, the count in the terminal node falls less than 10% of 1000, which is less than 100, right? I will not build that node further, right? So that I do not want the tree to be overfitted. I put in some criterias, I put in some parameters, and this will avoid overfitting. Is that clear, Idris, now? Yes? Okay. Everyone, this point is clear? Why we bring in some parameters? And we are going to do that. You'll see. When we build the tree, we will do that. Okay, clear? Okay. So let's proceed further. There are some assumptions that are made to for decision trees. In the beginning, the whole training set is considered as root. Of course, we had put entire data, training data, in the root node. Feature values are preferred to be categorical. These are called feature values, right? Feature values are preferred to be categorical, right? Like age, education rules. But if suppose a feature comes in, let's say income. Income is a numeric, right? If suppose there is an important feature which is not categorical, but which is numeric, right? How do you tackle that? We convert this income into income slabs, right? 0 to 100,000, 100,000 to 200,000, 200,000 to 300,000. Got it? So I have divided my income into 3 slabs, and now I will bring this variable as a feature and it will do the trick. It is going to then split. Then we are going to split, and this numeric has become a categorical variable now. Is that clear? This is clear? Why do we split? Sorry, why do we convert numeric into a categorical variable? So if the values are continuous, that is numeric variable, they are discretized prior to building the model. That is what I did. I said this is, I have discretized the data, numeric variable. Okay. So this becomes income level 1, right? Level 2 and level 3. Okay. Okay. Records are distributed recursively on the basis of attribute values. The order to place, yeah, this is important. The order to place attributes as root or internal node of the tree is done using a statistical approach, using some statistical approach. Now, you did not realize, and nobody asked me this question also, why did I bring in age first? Why did not I bring in education? Why did not I bring in employment first? Right? That's a very valid question, isn't it? Yes, isn't it a valid question that why did you bring in age first? Again, that is what it is saying. The order in which attributes are brought in for tree pruning or for tree construction or tree building is done using a statistical approach, you will check the correlation. Not exactly. You will. I'll discuss that. There are different approaches, right? We'll discuss these, right? I'm going to discuss only one of the approach. Then remaining three, maybe I've given a link. You can go through it, but there are different approaches you apply to decide which variable is going to come first. Okay. Okay. Before we go there, first we will quickly read through the advantages and disadvantages, and then working of decision tree is I've already explained, and how to avoid overfitting, right? So quickly let's read through the advantages and disadvantages. Easy to understand, of course, decision tree is easy to understand. Useful in data exploration. It is definitely useful in data exploration. It really helps you bring in some useful insights while you dig deeper in the data. Okay, then less data cleaning required. Data type is not a constraint. You have seen, if you come across uh, numeric data type, you can easily convert it into you can discretize it and use it. And it's a non-parametric method. Now, decision tree is considered to be a non-parametric method, means that decision trees have no assumptions about the shape of the data, right? Shape and spread of the data. There are no such assumptions. Hence, it is a non-parametric method. Is that clear? Is this clear to all of you? Assumptions? Okay. Disadvantages. Oh, sorry, these are advantages, not assumptions. These are advantages. Disadvantages. Overfitting. I discussed. Overfitting is one of the most practical difficulty of decision tree models. This problem gets solved by setting constraints on the model parameters and pruning. I've already discussed this. We will see when we create a decision tree in R, we will put some parameters to define that beyond that point, the tree will not be built. Okay. Not fit for continuous variable, though we can have a work around it, right? By converting, by discretizing it. But if directly a numeric variable comes in, it is of course not fit for it. Okay. Working of decision tree, I've already discussed it. Avoiding overfitting of decision tree. Overfitting is one of the key challenges faced while using this tree-based algorithm. If there is no limit set in the decision tree, it will give you 100% accuracy on the training data, training set, because in the worst case scenario, it will end up making one leaf in each observation. I discussed this. If I don't put a constraint, if I don't put define a parameter beyond which the tree will not be built, it will keep on continuing building tree as more and more variable will come in, and you will be left with only one data point in each, or one observation in each leaf node. Thus, preventing overfitting is pivotal while modeling a decision tree, and it can be done in two ways. One is setting the constraint, like minimum samples for the leaf or node split, right? If I can also define the minimum samples that I will be including when I split the node. I can also define minimum samples in the terminal node, right? Maximum depth of the tree, that is the vertical depth. You can also define that I will only go 3 levels deep or 5 levels deep. Okay. Then maximum number of terminal nodes. How many terminal nodes you would want? And remember, each terminal node is equal to each rule. So how many rules you want to create? You can fix that also. And maximum features to consider for split. How many features you want to be using in the decision tree? Like I have used only 2. You can decide I will use only 5 features. Not beyond that I will go. Is that clear? So that way you can set the constraints and avoid overfitting. The second way is tree pruning that I already gave you an idea. When that tree pruning is when you see that the tree is already built to an extent that it is now overfitting, becoming overfitted, right? You can prune the tree by moving up and clubbing the leaf node into a decision node and making, I mean, you can just remove that part of the subtree. Okay, that is called tree pruning. Okay, now selecting the best split. Let's do this. Selecting the best split after the break, and once you learn this, we'll immediately go to R. Is that clear? So, how do you select the best split? Like the order in which the variables come in. How do you select that order? This is that, right? Okay, so we'll discuss this after the break. Let's take a break for 17 minutes. Okay. And before that, I'm opening the poll. Please do participate in the poll and let us know how did you do in terms of pace and delivery. And the poll is open now. Please do participate in the poll, and I am putting a timer for 18 minutes. Okay. We have a good amount of time, so don't. I think timer for 18 minutes. Please do participate in the poll. I request all of you to please do participate in the poll. I am putting a timer for 18 minutes. I'll see you in as per the timer. Okay, please give me a confirmation if I'm audible. And thank you so much for participating in the poll. Okay, great. So let's continue. Now, as I said, the only thing left is understanding which feature we are going to bring in first and then which feature we are going to bring in next, right? So basically the order in which you will bring in the features, right? This can be done. I mean, there are four different ways you can bring in the features, but usually the most used are Guinea impurity and information gain, right? We are going to do Guinea impurity, but there are three more ways, though they are not in our, I mean, this feature selection is not in our curriculum, but I have included this Guinea impurity, right? In as much details. It's not in as much details, but we'll cover Guinea impurity in full detail, and then for remaining three, you can refer to this link. Okay. So node splitting divides the nodes into multiple subnodes to create relatively pure nodes, right? Different ways of node splitting are divided into four categories. Means how do you split the node using which features the that you can do in four different ways. Guinea impurity is majorly used for categorical variables. Information gain is used for categorical variables, right? Chi-square is also used for categorical variables. Reduction in variance is only used for continuous variables. Okay, so let's take a look at what is Guinea impurity with the help of an example. Okay, so this is an example. Let's say we have a sample of 30 students with three variables, right? What are the three variables? Gender, height, and class, right? So the three variables are gender, height, and class. Okay, so we have a sample of 30 students, and variables are gender, class, and height. And this is the split. I mean, between gender, it will be boy and girl, class ninth and 10th, height 5 to 6, right? So 5 to 6 means 5, we are going to split it less than 5.5 and greater than 5.5. Okay, these play these 30 play cricket in leisure time. We want to create a model to predict who will play cricket during the leisure time. In this problem, we need to segregate students who play cricket in their leisure time based on highly significant input variables among all these, right? So we have to decide among these three variables, gender, height, and class, which one should we bring in first. Okay, and of these 30 students, this is how the split is. For gender, 30 students, 15 play cricket, right? And these are 30 students, and of these 30, 10 are female, 20 are males. So that is the gender split. Okay, of these females, only out of 10 females, 2 play cricket. Out of 20 males, 13 play cricket. Is that clear? Is this clear? Okay, next. Next is height. If you look at the details of height, less than 5.5 students, 12 students are there who are less than 5.5. And of these 12, 5 play cricket. And on the other side, We have 18 students who are greater than 5.5 height and 10 of them play cricket. Okay. Similarly, if we take a look at the class, for class 9 students, 14 students are from class 9th of these 30 and 16 are from class 10th. And of these 14, 6 play cricket and of these 16 in class 10, 9 play cricket. Right? Is that clear? How is the split between the three? Now we will use Gini index. We are going to calculate Gini index, sorry, and we will decide which variable will come first in terms of order for the split. Okay. Okay. So what is Gini index? Let's understand that. For feature selection, for selection of categorical target variables, Gini impurity works with categorical target variables, success or failure, means it classifies into success or failure. It performs only binary splits. Okay. Higher the value of Gini, higher is the homogeneity. So what is Gini measuring? It is a measure of homogeneity of the variable, right? So higher Gini means more will be the homogeneity, and our ultimate aim is to make the leaf nodes as homogeneous as possible, right? If you can if you can just recall here in our example, the leaf nodes, can you look at the 4 leaf nodes once again? 1, 2, 3 and 4. Which among these is the most homogeneous? Can you tell me? Which is the most homogeneous? Leaf node 1, leaf node 2, leaf node 3 or 4? Fourth, others, do you also agree with it? And if you remember, it was easiest for us to take the decision there because we could surely take the decision for a homogeneous node, right? After this, which is the least, I mean, this is the least homogeneous, right? It was very difficult for us to take, or we could reject, we rejected it, right? Then between them, the the nodes which are okay, they are not homogeneous, but still they have high degree of homogeneity, right? You will take the decision based on other factors, right? So ultimate aim is to in, increase the homogeneity as, I mean, as far as possible, right? So Gini index is the index of homogeneity. CART means classification and regression trees using Gini method, uses Gini method to create binary splits. And as I said, higher Gini index split, sorry, higher Gini index implies higher homogeneity. Now, this is a formula for Gini index. We don't have to remember the formula. All you have to remember is that this, the algorithm that we will do, it will bring in the variables based on Gini index. Okay, Gini impurity. Okay, so nobody is going to ask you, okay, calculate the Gini index, but yeah, at the back end, the Gini index is used to uh, bring in the feature variables. Okay, so Gini impurity is also is equal to 1 minus Gini index, right? So where P is the probability of success of the event, right? Based on this, you calculate Gini, and 1 minus Gini index gives you Gini impurity. Okay. Steps to calculate. Calculate the Gini for subnodes using the formula for success P and failure Q, right? So this is the formula. Using this, we calculate the Gini index. Calculate the Gini index for split using the weighted Gini score of each node of that split, right? So let's see how we calculate the Gini index for these. For feature selection of categorical target variable, we have gender and I have class, right? So split on gender, I calculate the split on gender female. If you notice, gender we have females, and of these females, 20% play cricket. Means 20% is the success rate, right? So zero point 0.2 into zero point 0.2 p square, okay, and 80% is the failure rate. Means they don't play cricket. Q square, right? This will give you the Gini for the sub nodes. So Gini for this female node is zero point 0.2 square plus zero point 0.8 square, which comes out to be 68%. Gini for the male node 0.65 whole square, because 13 of the males play cricket, right? Of 20, 13 play cricket. So 0.65 whole square plus 0.35 whole square, which comes out to be 0.55. Now the Gini final Gini index is calculated simply as the weighted Gini for the gender split. So 0.68, you multiply it by weight of the females. Weight means the weightage, proportion of the females, right? 10 upon 30. And then similarly for males, 20 upon 30, I multiply by the Gini for males, which is equal to, and if you calculate it, it will come out to be 0.59. So this is your final Gini index for the gender split. Is that clear? How it is calculated? Is it clear? Please give me a confirmation, or if you have any doubt, let me know. Okay. Similarly, can you just quickly go through the class, split of class, and see if you understood this calculation? And if not, let me know. I'll give you 1 minute for this. Quickly go through it. Once you understood it and you've done it, type C in the chat window. C for class. Okay, great, Idris. Let's wait for some more confirmations. Okay. So Gini index for class split comes out to be 0.51, and here it came out to be 0.59, right? So among these, I am going to choose gender first. Remember the rule? Higher the Gini index implies higher homogeneity. So gender is giving me a more homogeneous split, right, than class. So I am going to go with gender. I am going to bring in gender as my first variable or first feature to split the data. Is that clear? Gini scores for split on gender is higher than the split on class. Hence, the node split will take place on gender. Is this clear? How the split is decided? Which split to take? Which variable to bring in? Okay, I think it should be clear, right? So let's now proceed to our studio and bring in, let's first install these packages: random forest, party, rpart, rpart plot, and reshape. After you have installed these packages, okay, let me share these with you. I think it will be easy. Otherwise, we would, that way we'll save some time. Okay, install these packages, and if you have not installed Carrot, install Carrot as well. And there are some more. So Carrot is one package which works for data processing, right? You will not see its usage on the front end, but it is used for data processing at the back end. Library, uh, I don't know if you have downloaded this proc, proc, not required. I think it will not be required. Uh, and color brewer. Okay. Uh, line number 24 and 28. First install the packages also. So install this package and then run library proc and also run R color brewer. It will only be required to add colors, otherwise as it is not required. Once you have activated these packages, library, right? Let me know. Okay, 28. If you're done till line number 28, type 28 in the chat window. Okay, after you have done 28, just after you're done with 28, I have shared this data set with you, right? Please get this data set. I mean, upload this, install this data set. Sorry, import this data set. HR data set underscore C. So if you'll see HR dataset underscore C. This is the dataset. I've already shared it. So I want you to look at the structure of this data. Let's view this, and I want you to tell me. We'll discuss this data in detail a little bit. Uh, but first, I want you to tell me how many observations are there across how many variables. Look at the structure and tell me. How many observations across how many variables? Correct. So 14,999 observations across 12 variables. Okay. Column names. This is just an additional uh, command. You might want to view only the column name, but yes, here there is an interesting thing that is happening. Uh, you'll notice role is there, salary is there, role code is there, and salary code is there. Yes. So always remember, I think I've discussed this earlier also. See, this is a simulated environment. We are learning. It's a learning environment, right? So I am introducing you to different data set, right? And but we don't have time to spend more time on the data set or and do EDA, right? But in a real environment or in a real scenario, you spend a lot of time on data before you start working with data. Okay, so whatever observations I'm going to show you, don't think that you were not able to observe these. These are observations that come when you spend lot of time with data. Okay, so if you will observe in our data set, as I said, role is there, salary is there. Then you have role code and salary code. So these are the role code and salary codes, right? So if you'll see, role code 1 is for sales. Role code 2 is for accounting. 3 is for HR and so on. Okay, similarly, salary codes are there. And how many salary codes are there? 3. So high, low, medium. Okay, so these are, so we will use either of them, right? I don't have to use both of them, na. Role and role codes are same, and salary codes are same. Same, they are categorical variables, so I don't have to use both of them. Okay, is that clear? So removing role and salary, as we are using role code and salary code. So we are just removing role and salary. Role code and salary code are called dummy variables derived from role and salary. They are called dummy variables. Now let me, because we have touched upon this dummy variable, it will be a good idea. I'll just explain you what dummy variables are. Uh, Question. Yeah. See, what are dummy variables? Many a times, uh, while preparing the data to be put in, to be used, preparing the data to be used in uh, models, right? We need to create dummy variables, right? So a dummy variable, also called a indicator variable. It is also called a indicator variable, is a numeric variable that represents categorical data such as gender, race, political affiliation, etc. Right? So what happens is, Technically, now in see in a decision tree, you can easily put. um I can easily use a variable that is not dummy also, right? But let's say in regression, wherein you will need only numeric variables, right? You cannot put non-numeric variables in regression, right? So in such uh, situations, or in when you are running a model like regression, you would want to convert a categorical variable into a dummy numeric variable, right? Technically, dummy variables are dichotomous quantitative variables, dichotomous and quantitative variables. Okay, their range of values is small. They can take only two quantitative or more than two also, but primarily two, right? As a practical matter, regression results are easiest to interpret when dummy variables are limited to two, 0 or 1. For regression, it is good, ideally it is advisable that you have only two dummy variables. Okay. Oh, sorry, you have only two values in the dummy variables. Typically, one represents presence and and zero represents absence. Usually, this is how you create dummy variables. But sometimes you also have to create dummy variables for a categorical variable like this, right? For example, this was our variable location, right? Now, I want you to, I want this information to be included in regression, right? So how can I include this information? There are three cities, four cities rather: New York, Dubai, Tokyo, and London. How can I include this in my and it's a very important variable. How can I include this in my as an input variable? For this, I can create three dummy variables. See, New York, yes; Dubai, yes; and Tokyo, yes. Right? So New York, yes means this city, the city is New York. So you select one for New York and rest all zero. Right? Rest all zero, only one for New York. Then you create a dummy variable for Dubai, yes. It will include one only for Dubai and rest all zero. Okay. Then third, you can we are including Tokyo. We are putting Tokyo as one and rest all zero. Right. So we have created three dummy variables which are in the form of 0 and 1, which can take only two values, 0 and 1. Is that clear? Is this clear how you create dummy variables when needed? Yes. Now, if it is clear, nobody asked me why did not we create a dummy variable for London. If it is clear, then you tell me why did not we create a dummy variable for London. Exactly this. Yes. Notice that when we have, see, using these three variables, I am able to capture the value for London as well. Wherever I have all the three zeros, it means the variable that is representing my London, city London. Is that clear? Right? So that's how you use dummy variables and do not miss a important information that is captured by categorical variables. Okay? Clear? Now, in our case, it is very clear that already, see, in our case we are doing a decision tree. We are creating a decision tree. So I don't need to do this for decision tree, because this for decision tree, I it is fine. I need categorical variables only, right? So I'm just dropping these two because these two and these two represents the same value. Uh, so I'll drop role and salary and include role code and salary code. Okay. So quickly let's drop. So in line number 48, I'm dropping role code and role and salary. Line number 48. Once I run line number 48, if you check now, I don't have role and salary. I just have role code and salary code. After this, I use attach, and I don't have to explain why I'm using attach. Attach HR, then class of role code and salary code. If you check the class of role code and salary code, what is it coming? What is it coming? Integer. Do you think this is the right class? What should be the class for a categorical variable? Not logical, factor. So also, if I check the class for role code and salary code is fine, but even if I check the class for left, it comes out to be, which is my dependent variable. Now, okay. Now, I think I did not discuss this data set. Quickly, let's discuss this. So we are basically, this is a HR data set wherein we have recorded, or we have taken data for some parameters, and based on these parameters, we will decide whether the person is going to leave the organization or he's going to stick with the organization. Okay. So left means the person has left, and uh, 1 means the person has left, 0 means the person has not left. Okay. So this becomes my dependent variable. Left is my dependent variable. Everyone agrees? So factor, I convert role code, salary code, left, and then work accident also into factor, wherein work accident is again a factor variable because it is 0 and 1. You can see whether the accident happened for that person or the accident did not happen. Okay, so convert these four into factor variable quickly, and then run the structure and summary of the data. Once you're done till line number 73, let me know. Once you're done till 73, do let me know. Okay, we'll wait for more confirmations. Okay, before we proceed, very important announcement that even though I don't know whether it is reflecting in your LMS, we have a class tomorrow. Is it reflecting in your LMS? Yes, it is. Okay, great. Thanks for the confirmation. So I assume others have done till line number 73. After you've done with line number 73, simply first thing we do is splitting. Yes, tomorrow is the last class. We'll be doing clustering. Okay, and uh, after clustering, if we get time, we will do that advanced statistics or Lubridate, right? Okay, so quickly, splitting the data, cross validation using sample. Using sample, I am splitting the data into two parts and I am deciding the probability. Okay, let me explain this. Sample, I mention I'm how many samples I have to create, which row, or sorry, which column HR underscore data. This is giving you the number of rows that are there in HR data. Okay. Now, of these, I am creating a sample, and of course, it will create sample randomly with replacement, and the two samples will be created with a probability of zero point 0.7 and zero point 0.3, where zero point 0.7 is my training data and zero point 0.3 is my, I'm going to put zero point 0.3 as testing data. Okay. So when you do this sample, use this sample in, and I assign a name to it, split index. If you see split index, how this is how it will look like. 1 for first option, which is my training data, 0 for second option, which is my, oh sorry, 1 for training and 2 for test data. Okay, so this is how your split index looks like. After this, I'm just putting them into train and test. Now, in line number 90 and 91, what I'm doing is I am just checking whether the ratio broadly for test and train, right, is zero point 0.7 and zero point 0.3. After in line number 90 and 91, I move on to 95 and 96, wherein I am calculating the proportion of these, and they should be more or less similar. You can see because the split between 0 and 1 is more or less similar. So it means they have been randomly split, right? The randomness is intact because in both the cases, the employees, those who left, are around 23-24%, and those who did not leave are around 75 to 76%. Okay, so more or less they are equal. So it means the data is um, randomly split. Okay, is that clear? Now, if this ratio would have been very different, right, then you would want to really think about, because maybe you will probably set the seed again and try to create test and train again, because this ratio should not be very different. It should be similar, and like in this case, it's very similar. Okay. So do till line number 96. Please do it till line number 96. Once you're done till line number 96, let me know. Am I audible? Am I audible? Yes? Okay, fine. Actually, my headphone, it just I mean, it got unplugged, so that's why I'm just checking. Okay, please continue. Line number 96. Oh, sorry. Yeah. Once you're done till line number 96, okay. Now make sure you have activated this library, RPart. Though I think even at the start we have activated this library. No, it's not. So yeah, it's RPart is activated. Fine. So make sure you have activated the library RPart, and RPart is the library that will create classification trees. Using, you can create classification tree using RPart, and left is our dependent variable on the left side. Tilde dot means all the variables on the right side. Then data equal to train split, that is our training data. Method equal to class means you are going to classify, use classification. So you will put method equal to class. Then you have this line control. Control equal to rpart dot control, and then I mention the minimum split and the complexity parameter. CP is the complexity parameter. Um, Minimum split means the at least the split will happen if at least 30 observations are there. Are you getting it? If a split will happen if the subnode or the subnode, yeah, subnode will have at least 30 observations. Is that clear? And complexity parameter is, as I mentioned, that 10%, that below 10% split will not happen. So 10%, 10% means the algorithm will stop splitting any node if it reaches 10% of the total. So in this case, if like, can you tell me what is how many observations are there in training data? Quickly run structure of training data and tell me how many observations are there. I think 10,500, something like that. If I'm correct, yeah, 10,503. So if there is a node wherein observations are falling less than 10% of this, that is 1050, right? Algorithm will not proceed further there. Okay? Is this clear? Is this point clear? Minimum split and complexity parameter. It depends on you. You may only specify complexity parameter. You may only specify minimum split, or maybe some other variables or some other parameters. Okay. So I run this, and then when I run the model fit, this will give you how the split has happened. First, this is my root node, 10,610. I think I did not do set seed again. That's my. Let me quickly do it. Set seed. Otherwise, we'll have different results. Set seed. Let me split it. Training and test. Okay. So now, if I see, it comes out to be exactly same as yours, right? So now what happens is, this is the, you can say, not, this is the decision tree, right? This is the decision tree, but of course it's not visually represented. But let me explain. First, root node is there, right? It has 76% zeros and 23% one. First feature that comes in is satisfaction level greater than 0.465, right? It divides into 0 and 1, right? These are the zeros and these are the ones. Okay, this is the percentage of these two. Okay, and notice the star means it's a significant variable. Then second variable comes in. Sorry, this is satisfaction level. This is the other leg of the satisfaction level. This is greater than and satisfaction level less than. This is how the split happens, right? And 0 and 1, this is here 1 means, and this represents 0. Okay. So then second variable that comes in is number of projects. It's another variable. If you'll see, number of projects, right? That variable comes in and it does the split, right? So this is difficult to read. So if you use rplot.fit, it will give you the pictorial representation of this decision tree, right? rplot.plot fit. Can you see? It gives you the pictorial representation, right? The chart, decision tree. Okay, structure of train split. Yeah, we don't need a oh yeah, we need this training split. This is the structure of the training split. Uh, just checking. I'm using it just to check here, right? How the split is happening. Okay, so this chart is going to give you the decision tree, and notice how the rules have been created. First rule is satisfaction level greater than 0.47, right? And this is the first rule that has been created. Okay. Then second rule is satisfaction level less than 0.47 and projects greater than 3, right? It gives you the second rule. Project satisfaction level less than 0.47 and projects less than 3. And again then satisfaction level comes in here. Notice the satisfaction level is a key variable here, very important variable, right? So again satisfaction level less than 0.12 comes in here, where you have satisfaction level less than 0.47. Again a satisfaction level comes in and it is split at 0.12. Okay, and it again creates two more rules. Is that clear? So this is one rule. This becomes my second rule. This becomes my third rule. And this becomes my fourth rule. Is that clear? And this is of course the first rule. Is this clear to all of you? Okay. So that's how you create a decision tree. Now once you have created a decision tree, rules have been created, I can just print the summary, print and summary. Now summary gives you a very detailed view of everything, right? Complexity parameter, the errors in it, variable of importance, then how the variables come in one by one, right? Node 3, every node it gives you the detail of that, right? So this is the node 7, how it got created, node 12, how it got created, and 13, and all this, the entire detail is given in, yeah, there are 4 leaf nodes means, correct. So there are 4 rules. Okay, Idris? Okay. So next, what we'll do is we will use predict as we have been doing it earlier. Predict using trained data and type is equal to class. I predict whether based on the training data, how will my whether the person will leave or not, and then based on this training data, I create a confusion matrix for training data. Okay. Wait, I have predicted fit train split. I think I did not convert it into, I did not run this. So that is why it says now it should work. Yes. So when you create a confusion matrix from for the training data, though you can straight away create a confusion matrix for the test data. I am just creating it for the training data just to get the understanding on accuracy. So in the training data, my confusion matrix is giving me an accuracy of 91%. And what I'll do now, I'm going to use this in the PRED test, right? And PRED test will give you the accuracy rate of 90%, I think. PRED test, right? It gives you an accuracy rate of 90%, which is in the same range, right? It's not a, there is not a the stark difference between the accuracy rate in uh, accuracy rate of train data or test data, right? So you don't have to create the accuracy rate for training data, only create a prediction for test and then the confusion matrix. Do it till 145. Once you do it till 145, let me know. If you want me to scroll up, let me know. Otherwise, once you're done till 145, let me know. I'll wait for more confirmations and then we will move to random forest. I think we will cover random forest theory only today, and tomorrow we will continue this same example, right? We are going to continue this same example for random forest. Okay. So, but theory of random forest will cover today. Okay. Thanks for the confirmation. Okay. Now, if you remember, I discussed earlier that if you don't, if you're not sure which model to use in your data, or you are doing, or you have created multiple models for the data, right? And you're not sure which model to use, simply use random forest. Random forest is uh, a sure shot model. Now, don't, I mean, think that okay, it will give you the results in every damn situation. Not possible. But yes, in most situations, random forest works well. Why is that? First, tree is to forest, right? What is the relation between trees to forest? Forest is a collection of trees, right? On that same logic, Random forest is an ensemble of decision tree. 500 trees, six. I mean, it can you can decide how many trees you want to build, right? How many trees you want to build, and based on those, you create, you take the decision. So it's like very simple. I mean, I'll just give you an analogy. When you, let's say you want to buy something on Amazon, right? So there are two products. I mean, two options you have. Option one has mostly when we buy something, we look at the ratings. Yes, right? We look at the ratings. Option one has only 1% rating. It, right? Whatever is the rating, it has only 1% rating. And option two has 1,000 people rating, and the rating is out of 5, it's 4.5. So which among these you will prefer, one or two? Option two, obviously, right? Because you can see that the ratings, there are 1,000 people recommending this, right? On that same logic, tree is like a single person. You go to a single person and you ask. There's another example I've given in the next slides. Suppose you want to buy a house, right? In a new city where you have not been to that city, right? And you ask one of your best friend. You ask your best friend whether I should buy a house there in the city Y or not. He will give you some suggestion, right? Okay, you go ahead and buy, right? This is one option. Tree option. This is a tree option. I have just gone to one friend and asked his suggestion. Next option, random forest suggestion or random forest approach. I asked this question to 20 of my friends, right? Whether I should be moving to the city or not. And I take a maximum, what do you call, take a approach of majority voting, right? Which among these is a better decision? Which among these is expected to be a better decision, or most likely it would be a better decision? Second case, again, when you are discussing the decision with 10 or 20 friends and then taking the decision based on their opinions rather than just going to your best friend and taking the decision. Are you getting it? That is the difference between random forest and decision tree. In decision tree, you are just building a single tree and taking a decision. It can be highly volatile, right? But in random forest, what do? You build lot of trees, right? 500, 200. That is the number of trees your model is going to build, and then based on those, you take the decision. Is that clear? Is that clear? The logic, the concept part is clear? Am I audible? Okay. Thus, a collection of models is used to make prediction rather than an individual model. Right? So random forest is an ensemble of decision tree. Ensemble simply means combining multiple models. Thus, a collection of models is used to make prediction rather than an individual model. Now, it builds decision trees on different samples and take their majority voting for classification and average in the case of regression. So if my dependent variable is categorical, I am going to use majority voting. If my dependent variable is a continuous variable, I will use average, right? So It is a supervised machine learning algorithm that is used widely in classification where categorical and regression where it is continuous problem. Random forest is more robust than decision tree as it involves many decision trees to make the final decision. Is that clear? Is this point clear? This slide, any doubt, let me know, else we'll proceed to the next. Okay. It also undertakes dimensionality reduction method, treats missing value and outlier values and other essential steps of data exploration and does a fairly good job. Random forest is considered to be panacea for all data science problems. On a lighter note, it is said when you can't think of any algorithm, use random forest, right? So that's now this is a random forest approach wherein you build 200, 500 trees, and based on those, you take the majority voting. For example, tree 1 gives you an, that answer as class A. Tree 2 gives you an answer as class B. Tree N gives you an class A again, right? Now, of these N trees, I am going to do a majority voting and then select. I selected class A because it was the majority of the trees were voting for class A. Is that clear? Now this is the example that I just discussed with your friend. If you want to shift the city, confusion matrix, ROC, these remain same, right? So I think what we'll do is tomorrow we will continue with random forest. It will not take much time, right? And then we will start with clustering. Is that clear? Right. Otherwise, if we'll start with random forest, it will take 15-20 minutes. So let's continue with random forest tomorrow. Okay. Then thank you so much. We'll continue tomorrow. Tomorrow is the last session, and make sure you be all of you are there because clustering is a very important topic. Random forest will complete, and then depending on how much time is left, I'll show you some more interesting packages which can really come handy to all of you, right? Okay then. Take care and goodbye. Thank you. Goodbye.
Thank you for watching the session. Once we wrap the session, you can see a feedback survey form in your browser. If you like the session, please rate us 5. For anything less than 5, please share your comments to help us understand what went wrong. It will help us to improve the upcoming session. Thank you all for your time. Take care. Thank you, sir.
Okay, goodbye.